Welcome back, Seraphin here, and today we're making this. To many different people, this is something entirely different. It could be a fizzy drink, it can be made into vinegar, we can make bread with it immediately, and we could also use it to make a sourdough starter. That's because the purple liquid inside this bottle is actually a surprise party of healthy nutrients and beneficial microorganisms. Okay, this is fruit yeast water. If you followed this channel for quite a while, you would remember that at the onset of the pandemic, January 2020 to be exact, we made a video on fruit yeast water just a few months before the scarcity of instant yeast hit the market. Fruit yeast water comes quite naturally to us. We live on an island with many types of fruits in season almost all year round, quite abundant actually, with a daily temperature that falls between 27 to 31 degrees Celsius, making it ideal for the fermentation activities of many beneficial microorganisms. And along with the widespread information on the process online, we were also pretty familiar with it. So we made a video. After more than 3 years, it's time for an update. We're also going to use this fruit yeast water to enhance our sourdough starter or start a new one. For the fruit yeast water of this video, I'm going to use some local grapes. Our organic local grapes have never ever let me down before. 0 failures so far. In choosing the fruits for our fruit yeast water, we always try to go for local organic fruits to avoid the unwanted pesticides, fruit waxing, and other preservatives, residues that may end up killing the wild yeast and other beneficial microorganisms that we are looking for. We're going to use this 1-liter glass jar with an airtight glass lid that we have sterilized by dipping it in boiling water for about 5 to 10 minutes. Then 200 grams of local organic grapes. You want to sanitize the fruits, but you don't want to sterilize them, by which I mean you can wash them to get rid of any dirt or debris if there are any, but never sterilize the surfaces so thoroughly that you end up wiping out all the biofilms along with the inhabitants, the beneficial microorganisms that we want. So I remove the grapes from their stem one by one, chop them up one by one. This is going to take a while, but you don't want to chop them together like this, as the juices and the pulps will spread onto the cutting board. That will be a big waste of nutrients for our wild yeast and other beneficial microorganisms. You can also crush them in the jar, but I found out by cutting the local grapes one by one instead of squashing them, I can make 2 batches of fruit yeast water with the same amount of fruits, all by simply adding more sugar and water after this batch is done. Of course, this is my experiment with our local grapes, and it may not be applicable in your situation. After the fruits, we go on to pour 600 grams of clean water over it. We use mineral water or spring water. If you're going to use tap water that has gone through chlorine treatment, you may want to boil it for at least 15 minutes to get rid of the chlorine, and use the water once it has cooled down to room temperature, or alternatively, leave a jar of water uncovered at room temperature for at least 24 hours. That should also get rid of most of the chlorine in the water. And finally, we're going to add in about 2 teaspoons of sugar, about 8 to 9 grams. This is going to be extra food that speeds up the activity of the yeast. If you crushed your grapes in the jar, you can skip this optional step. You do need to add more fruits though, as mentioned in our older video. After the sugar, we're going to cover the jar to prevent any contaminants from getting in. Make sure it's properly sealed. And then we're going to give the jar a good shake just to mix everything together. Alternatively, you can also give it a good stir to mix everything together. And after stirring, we cover it and let the fermentation begin. On day 1, we're not going to see much activity. The chopped grapes are at the bottom of the jar, piled up, nice and cozy. We can presume that the yeast is adjusting to its new environment. In this lag phase of the yeast life cycle, the cell count has not changed. But since we've given them these ideal conditions of abundant water, sufficient nutrients, and the right temperatures, 28 to 31 degrees Celsius, the yeast is pretty much sure to thrive. We should expect to see some action take place the next day. If your room temperature is way below the temperature we have here, fermentation will be slower and it may take longer. In that case, I'd suggest you place the jar near something that can radiate sufficient heat to warm up the jar. Without that step, the fermentation process may take way longer than what I describe here. Day 2, we can see bubbles gathering at the top, and some of the grapes are floating to the top as well. This is a good indicator that the yeast is in its growth phase or exponential phase. Cell division occurs, resulting in a rapid increase in total cell count. Fermentation is happening fast, but we can't rush to assume that the job is done. We have to let the yeast water be for a few more days to ascertain that these bubbles are not coming from other unwanted or even worse, harmful microorganisms such as pathogenic bacteria or molds. To make sure there is no mold forming at the top of the fruits, we can shake the jar a little to get the top part of the floating fruits all wet. This agitation will trigger the release of carbon dioxide from the liquid. So after a bit of shaking, you can see more and more bubbles flowing up. It's a beautiful sight to behold, but try not to overdo it. We want most of the carbon dioxide to stay in the liquid because a part of this dissolved carbon dioxide reacts with water to become carbonic acid. It is the hydrogen ions or protons present in carbonic acid that make water acidic, lowering the pH. Our goal at the end of this multiple day process is to have a fruit yeast water with a pH lower than or at least equal to pH 4.5 because most foodborne bacteria can't grow at these pH levels. To minimize carbon dioxide escaping from the jar, we usually cover our jar with an airtight lid. Here, as an extra measure, I use a silicone cap underneath the airtight glass seal for extra sealing. Sealing the jar also serves another purpose. It has to do with the yeast in the jar. In the presence of oxygen, yeast undergo aerobic respiration and convert carbohydrates or sugar source into carbon dioxide and water. By sealing the jar, we limit the availability of oxygen, and in the absence of it, yeasts undergo fermentation and convert carbohydrates into carbon dioxide and dozens, if not hundreds, of chemical compounds via metabolic byproducts. The intermingling of these chemical compounds results in the complex flavor and aroma of our fruit yeast water. At day 3 or 4, when you open the jar, you either get undesirable off flavors or an assortment of fruity aromas. If you get the latter, your task is mostly done. You can strain the yeast water into a container and start using it. If it's the off flavors that you get, then you need to repeat the routine. Shake the jar to wet the top parts of the floating fruits and then leave it to ferment for 1 or 2 more days. Now, where do these off flavors come from? In the first place, we need to understand that our sensory perception varies when it comes to the flavor that is coming out of a fruit yeast water jar. That's added to the fact that each of us have different experiences and perceptions of any specific flavor that we are sensing. Take durian, for example. Ask people who hate it, and you get a wide variety of descriptions on how bad it smells and tastes. These descriptions would mostly bemuse people who love durian because they smell and taste the same flavors and perceive them entirely differently. I know a lot of people who pinch their noses at durian, but personally I think it smells like sweet custard cream. The same thing applies in fruit yeast water, and to top that, the chemical composition of the fruit yeast water can be very different due to the interactions of the unpredictable wild microorganisms and the different fruits we use. Hence, our individual response is the outcome of complex biological and chemosensory interactions that are difficult to predict because of the influence of so many variables. Thankfully, though, a basic understanding of these biochemical reactions is all that we need. So in a very simple explanation, our fruit yeast water contains a very large amount of flavor and aroma active compounds, the results of the synthesis of complex molecules from simple molecules such as sugars or amino acids during fermentation. Some of these compounds are desirable, while others are considered off flavors and should be minimized. In our case, grapes have numerous amino acids. Let's take a look at what happens to one of them, leucine. During fermentation, the yeast degrades leucine into an isoamyl alcohol, a type of fusel alcohol, also called fusel oil, which derives its name from the German word fusel, bad liquor. While fusel alcohols at high concentrations impart off flavors, low concentrations of these compounds and the esters that they subsequently turn into upon further fermentation make an essential contribution to the taste and aroma of our fruit yeast water. So when you open the jar and get that off flavor aroma, chances are that your fruit yeast water is still in the work of fermenting the fruits. Leave the jar for longer, and the next time you open it, you might get a banana fruity flavor instead. The aroma of isoamyl acetate, an organic compound that is the ester formed from isoamyl alcohol and acetic acid. The source of the acetic acid, think vinegar, can be from the oxidation of ethanol. A small amount of acetic acid is acceptable, but when there's too much, it literally becomes vinegar, which makes our fruit yeast water unusable as a leavening agent for our bread. Depending on the fruits we use, there can be many types of volatile esters. They contribute one of the most important classes of aroma compounds and are largely responsible for the fruity aromas associated with our fruit yeast water. Once we have our fruit yeast water ready, we can make it into poulish, my favorite kind of pre-ferment, and use the poulish at its peak as a leavening agent for our bread dough. This is what I used to do in my previous experiments with fruit yeast water years ago. But I've revised the way I use it now. I'm using this fruit yeast water to make a sourdough starter. Of course, any which way you start your sourdough starter, in the end, the local microorganisms will dominate. It doesn't really make much difference, but it will still add the grape's antioxidants and other nutrients into the starter. And it does speed up the starter's progress, especially at the start. And although the initial microorganisms from the yeast water might get phased out, what if we occasionally add fruit yeast water into our sourdough starter? Say during the occasional backsloppings, instead of water, we use fruit yeast water, maybe like once every 3 days. In doing so, besides the usual rejuvenation of our sourdough's microbial cultures, we would also introduce flavor and aroma precursors from the introduction of fruit yeast water. From our previous experiments with fruit yeast water, we know that there will be only subtle sensory notes of the fruity taste or flavor in the bread we make, but isn't that exactly what we want? A light touch of a new sensation mixed with the already complex flavor of our sourdough bread. So to make a sourdough starter with our fruit yeast water, we mix 100 grams of flour with 100 grams of fruit yeast water using chopsticks or a fork until all the flour is incorporated. This usually takes just a few minutes. We then cover the jar and let it slowly ferment until it peaks. If you recall the many videos on fruit yeast water we made, these are actually the exact same steps we do when making a poulish with fruit yeast water. It usually peaks at around 10 to 11 hours after mixing. Our room temperature averages around 27 to 28 degrees Celsius, so expect longer fermentation times if your room temperature is colder. Once it peaks, you can use all or some of it immediately. In that case, you can actually using a poulish, or you can follow up with the procedure of backslopping. So you take 1 part of the starter, add 1 part of water and 1 part of flour, weight by weight, of course. I usually take 70 grams of the starter, add 70 grams of water and 70 grams of flour. This will make the total weight of the mixture about 210 grams, roughly equal to the amount of the starter we began with. Now, what are we going to do with the leftover, the 130 grams of discard? One thing for sure is that I never really throw it away. Unlike when starting out with a regular sourdough starter, there are no leftovers here. One of the main differences between making a sourdough starter with fruit yeast water and a regular sourdough starter is that a sourdough starter made this way is actually ready from the get-go. The fruit yeast water is already full of active and beneficial wild organisms, along with dozens, if not hundreds, of fruity organic compounds that we can make use of. So even at its very first peak, it's already fully loaded with all the goodies we want. So then why do we backslop it? Because we want to have the organic compounds from the fruit yeast water that we like and the beneficial wild microorganisms of both the fruit yeast water and the flour. While fruit yeast water brings in beneficial wild microorganisms, they are more or less dominated by the yeast culture. A regular sourdough starter has a totally different culture of microorganisms, dominated more by lactic acid bacteria, that have been shown to bring us so many natural health benefits and more. Combining both of these can be an exciting new frontier for us to explore. After the first backslopping, you can continue with the regular schedule of feeding a sourdough starter without using any additional fruit yeast water. In that case, after a certain period of backslopping, you're going to end up with a pretty much regular sourdough starter, because what we did was just jumpstart the process of making a traditional sourdough starter by using fruit yeast water to give the cultures a better environment to thrive in and eventually take over. But let's be a bit more audacious. What if we say, from time to time, introduce new fruit yeast water into the backslopping routine? So instead of using water, we use fruit yeast water. This, of course, will also work with your regular sourdough too. So instead of throwing away the discard of your mature sourdough starter, starter, you can experiment with adding fruit yeast water. To adjust this new sourdough starter to our personal preference, we can adjust the timing and also alternate the fruits we use. This will bring a whole new world to our sourdough starters, giving us a more complex sourdough with even wilder sensory notes that might give our home baking an extra push to a new level. And that's one of the major goals I want to achieve, so stay tuned, and that's it for this video. Thanks for watching, and leave your comments below. Tell me what you think. I'll try my best to answer as many as possible. Bye!